Hello. In recent videos I started to showing you a more professional equipment. We can call this a commercial grade. I show you the Motorola DM4601, the DMR UHF radio that is capable of transmitting the digital TCP/IP data. Then I show you how I label the coax cable that are going to be a feed line to the antenna tower. And here in front of us I've got a dipole array antenna. Because of all this pandemic situation and delays, I managed to get it into home so we can play. This type of antennas are very expensive because they are made for a commercial application, and they are quite complicated to build because this is a 4 folded dipole elements connected together. And what's the problem with them? The problem with them is they need to be like a phase shifted, so they are work in exactly concert, because this is just, we don't want them to interfere together and, for example, cancel each other. I'm not sure if you are familiar, but there was a small box that was called a phaser, and it was used for removing the QRM noise that you can have inside your radio shack. And how this device was built, it does have two antenna ports, and one of the antenna port is the antenna that was on your rooftop, and the second antenna port was for a tiny antenna in your shack. And you've got a dial on these devices. And how it was working that you can shift the both signal from your top antenna and your shack antenna, and if you shift them on top of each other but slightly move with the sine wave, so they are canceling each other, and you can read off a noise that, for example, is made by your power supply just by finding the right point. But of course, on the phaser, the idea was to grab the opposite slope so they can cancel each other, like on the headphones with a noise cancelling feature. But here is exactly the opposite, because we would like to have a additional gain when these four antenna receive signal in the same time. So it's quite important to make it right, and making a 4 element is just a crazy stuff. I'm pretty sure that is possible, but you definitely need to like spend a lot of time of calculating and making measurements. So yeah, sometimes it's better to buy a ready element. And this came from Ukraine. This is because they've got a really good price on the antennas if you compare to the other companies and other places. So yes, very good. We are going to take a look, and I'm going to play with this until I need to get it to the mast. So this is how it's going to be mounted on the mast. Here is going to be your, I forget if that was a quarter wavelength or 5/8. Yeah, I don't remember, but you have to keep the distance between of center of these folded dipoles as a spacing. And also there is a second spacing that you can change, and you can change the horizontal radiation plane by shifting how far or how near they are going to be from the mount pole. And I bring a couple of radiating pattern. This is from a different antenna, but I would like to just show you how it looks like and how to very quickly read that type of H-plane. So first of all, in general, you might think that when you've got a lot of gain, then the antenna will be working better, but that's not always the case. That's very depending of your real world conditions. So sometimes I was removing the high gain antenna and I was putting a low gain antenna, and people start being happy with having a better reception. And why this is happening? Here is a radiating pattern from a Yagi-Uda antenna, and here we've got a gain of this antenna and is a 9.3 dBd. So this is a decibel over dipole, if we put a dipole element as our reference point. So you have to stay away from antennas that doesn't saying the dBd, because there is something going wrong. There is in some cases where people are putting the dBi over the isotropic antenna, but in general, if someone is using the dBi, then they just want to have a higher number to lure you into buying their stuff. So let's take a look at this antenna. This is a Yagi-Uda, as I told you, and this is a very directional antenna. What does it mean? That this antenna will be working perfect in the direction where it's facing, and as you can see, this gain you are going to be have in that range, in that direction. And this is like a 360 degrees around the world viewed from top. So if we point our directional antenna like this, here will be the reflector, and here will be the driving elements, the radiators. So this is what you are going to see. And very important thing is how to read that. If you don't familiar, you have to know that this is not something that you can put on your map. This is just showing you the gain as a logarithmic scale of the signal. So you cannot print this on a transparent foil, put on top of your map like a real world map, and you are going to see that your building, for example, is located here, and oh, I'm not going to have any reception from that point, because it doesn't work that way. And I'm going to show you how this works. So this is just like a world direction, where this is our north and so on. And if our base station would be in this point, we are going to get the absolutely highest signal. And if our base station is here in that direction, it doesn't mean how far it will be or how close. You grab a straight line and go here, and on the edge of this you are going to get the how it's going to be, how signal is going to be affected. So in our case, this point will be -3 dB. This is how this signal is going to be weaker in compared to this point and the antenna gain. So it's not like here I'm not going to work it have absolutely no compared to a real world map. This is just how a direction and how signal is going to be stronger or weaker. This is how it works. And if our base station will be here, as I said, it doesn't matter if we are here. If we are here, we are going to straight in this line and we are going to locate, and there is a minus 20, so 60 and so on. So here we are going to not get signal because that signal is going to be attenuated that much from this number. So this is how this works. So as you can see, if we are not going to have a point to point between those two base stations, then these antennas will be very poor, because if we go here with our patrol car, then we are going to get a very high attenuation of the signal. So what will be the best antenna? The best antenna will be a omnidirectional antenna. Here I've got what I believe that was a folded dipole. This is not this antenna. I'm just showing you a random piece of that I find in the Google, and it have gain of 2.6 dBd. So what I believe that this is a folded dipole, because if that would be just a regular dipole, that will have a 0 dBd. And how this looks like, as you can see, you've got almost omnidirectional, and that's mean no matter in what direction you are going to be standing, you are going to see almost the same antenna, almost the same gain of the antenna, almost the same signal strength. So if you've got like a Motorola radio that is showing you the actual signal strength, you can compare, and here you are going to see that you are going to lose this free, or maybe not free, you have to go around the cycle. So that will be like the between, this is the logarithmic scale. So yes, this is how it looks like. And now we can take a look at our folded dipole array antenna. And if you are going to be affecting the mast to the driving element distance, you can get a couple radiating pattern. This is a spacing, and by the way, these antennas you are ordering them by giving the center frequency that is allocated to you. So they are manufactured exactly for the right frequency to get the maximum antenna gain. And here you can see a couple of examples. If you are planning to get most in that area, so you are going to face into one side of your city or your repeater, that's depend. This might be interesting, the quarter wavelength spacing, but I believe we can go with something like this. This radiating pattern looks really nice. It's very, very close to the omnidirectional. As you can see, we are losing somewhere in front and back, but it's really nicely on this side. And here is another example. We've got a very nice gain in that area, a little bit less on the back. So yes, this is how it looks like. And if you take a look here where I put this chart, because this is why I would like to show you this and compare. Because if you take a look here, maybe that will be better showing you the difference between the antenna array and the Yagi-Uda antenna. Both of these antennas have a similar gain, as you can see. They are very similar, but here you gain this signal strength by removing that area. So all of here your signal is weaker, and here on the array antenna you've got this gain, but still you've got a really nice area that's going to have a high signal strength. So this is the main difference that you have to keep in mind, that you have to really pay attention to the H-plane, because you might end up in buying high gain antennas and you are going to see like, whoa, but whenever I'm in that area behind the antenna, on the side of the antenna, I've got a bad reception, or I've got a bad transmit. So this is not something that you have to keep attention on the listings on eBay, when someone is having you saying that, oh, that antenna is that and that gain, because you might end up in having a worst performance than having just a folded dipole, which has lower gain, but if you are going to stand behind the antenna, you're going to get a better reception. I hope that's clear. And let's take a look at the antenna. So as I said, I've got this from Ukrainian company. So this was a factory manufacturer, and they ask for you have to provide them with the frequency that's going to be this antenna working. We've got a mounting for a mast. The input of the antenna, like most of the UHF, VHF, is made of the N connector. In most professional systems, this is what you are going to get. The popular UHF connector is mostly found of the HF radios, but anything higher, the name is a little bit confusing because UHF sounds like UHF, but it's used on the HF. Many years ago, they call UHF much lower frequencies. Yes, so we've got, looks very nice. That looks like the RG8 size cabling. Very nice protection against the water. And as I told you, this is very expensive stuff, and you might have a feeling that this is like a stealing money, that just a couple of metal elements cost that much, but really this is just a price for the manufacturing it, tuning it, and making it working good. This is why this is so expensive. And as you can see, they are joined together and still looking quite nice. This is first time that I've got that type antenna from a Ukrainian company, that the price was so right that we decided to give it a try, and this whole COVID situation just pushed us to testing something else. And I expect this is a place where they are tuning this. Maybe they are cutting the internal part. And for the mounting, there is important that you have to keep this hole that is going to be draining water in the bottom, so it can fall off. And as you can see, these two elements go into another splitters and go like this. This is quite a beefy antenna, even this is a UHF. But yes, this is how looks like a professional folded dipole array antenna. I'm going to play with this. I'm going to go outside, do a couple of tests, and then take it back to the place where it's going to be mounted. So here you go, folded dipole array antenna. Thank you very much for watching. See you next time, and bye bye.